Okay, I'm going to have a look at non-linear graphs. So linear graphs are straight graphs, non-linear are curves. I'm going to start off with quadratics. The basic quadratic shape is a U-shaped curve. It can go just touching there at the origin, that's a y equals x squared graph. It can go through a point on the x or the y-axis. That graph is showing you y equals x squared plus 3, so basically the x squared graph has been lifted up 3 units. And this one here, it can cut the x-axis twice. So that's an example of a graph, y equals x squared plus x minus 12. A negative x squared graph is just the x squared graph upside down. So that's x squared, that'd be negative x squared. Again, that graph could be lifted up 3 and look like that. Or it could be an ordinary negative x squared graph plus x minus 12. Next type of graphs we're going to have a look at are cubics. That's to the power of 3. So you've got your basic cubic x cubed. If you have x cubed plus 3, you're lifting that graph up 3 units, like there. If you have other x terms, so it could be x squared plus, or x cubed plus x squared plus x plus 5, but as long as it's x cubed plus other x terms, you get the 2 bumps in the graph. Starts down low and goes up, then down and up. Negative x cubic graph starts off high and go down. That's the negative x cubed graph. Lift up 3, starts off high and goes down. Again, if it's a negative x cubed plus other x terms, whether they're x's or x squared or whatever, it starts off high, down, up and down. It's got the 2 distinct bumps in it. Next type of graphs are exponential graphs. An exponential is where x is the power. So y equals, a stands for any number to the power of x. So y equals 3x, y equals 10x, any of those will look like that shape. Start off low, go through 1 and up. The reason it goes through 1 is because that's in the y-axis where x is 0. And anything to the power of 0 is always 1. If you've got a negative exponential graph, it starts off high and goes down. A reciprocal is 1 over x. It's a graph that's split into 2. A negative reciprocal, so negative 1 over x, it just goes across the other 2 quadrants. Trig graphs. Your sine graph, y equals sine x, goes up to 90 and 1, down to 180, down to 270 at minus 1, then up to 360. And that will repeat itself every 360 degrees. Your cos graph starts at 1, goes down to 90, goes down to 180, which is down to minus 1, up to 270, then up again to 360, which is at 1. And again, it would repeat itself. Your tan graph has got these asymptotes. The asymptotes are lines that the graph skims along but never touches. It's got an asymptote at minus 90 and at 90. So it skims along, never touches it, goes through 0, and then up and skims along that 90 asymptote. Then asymptotes down here, goes through 180, and asymptotes again at 270. We're going to have a look at drawing some graphs. To draw a curve, you must work out your points. So we'll do a wee table here. So x is between minus 5 and 2. So minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1 and 2. And you work out your y points. So we draw this up here. I like to start off with the positives because I find it easier. So 1 minus 3 2s are 6 minus 2 squared is 4. So that's 1 minus 10 is minus 9. Putting 1 in, 1 minus 3 minus 1 gives me minus 3. Putting 0 in, 1 minus 0 is just 0. Now be careful when you're working out your minus 1s here. 1 minus 3 times minus 1 is positive 3. Minus, now be careful here, x squared minus 1 squared is 1. So it's minus 1, which gives you 3. Putting in minus 2. So it's 1 minus 3 times minus 2 is positive 6. Minus, now do your squared bit, minus 2 squared is 4. So you get 7 take away 4, which is 3. Now doing minus 3. So it's 1. Minus 3 times minus 3 is positive 9. Minus x squared minus 3 squared is 9, which gives you 1. Now putting in minus 4. So it's 1. Minus 3 times minus 4 is 12. Minus 4 squared is 16. So 1 add 12 is 13, take away 16 is minus 3. And lastly, minus 5. So it's 1. Minus 3 times minus 5 is plus 15. Minus 5 squared is 25. So you get 16, take away 25, which gives you minus 9. Now I'll very, very quickly just sketch this over the side. Quite a rough looking graph. It's a negative x squared, so I know it's going to be n-shaped. My lowest y value is minus 9 and my highest one is 3. So I'll draw my axes in here. And we've got 1, 2, minus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2. Make sure your scales are nice and even. Minus 5, minus 6, minus 7, minus 8, minus 9, and 1, 2, 3. Minus 5 goes down to minus 9, minus 4 goes to minus 3, minus 3 goes to positive 1, sorry. Minus 2 goes to 3, minus 1 goes to 3, 0 at 0, 1 at minus 3, and 2 at minus 9. Now when you plot these, when you come here, you must curve this bit. Although it looks like it's going straight across, it must be a nice curve. So it'll be something like that. I'm going to draw a cubic graph for x between minus 3 and 3. So we'll draw a wee table of values here. Minus 3, minus 2, minus 1, 0, 1, 2, 3. And work out the y's. Again, I like to start off with the positives. Remember, do the power bit first. 3 cubed is 27. 27 times 2 is 54. Add 3, 57. Now putting in 2. 2 cubed is 8. 8 times 2 is 16. 16 add 3 is 19. Put in 1. 1 cubed is 1. 2 times 1 is 2. Add 3, 5. Put in 0. 0 cubed is 0. 2 times 0 is 0. Add 3. Now be careful with your minus 1. Minus 1 cubed is minus 1. Minus 1 times 2 is minus 2. And then minus 2 plus 3 is 1. Now put in minus 2. Minus 2 cubed is minus 8. Times 2 is minus 16. So that becomes minus 16 plus 3 is minus 13. And lastly, put in minus 3. Minus 3 squared is minus 27. Times it by 2 is minus 54. Add 3, minus 51. And I'll do a wee quick sketch over here. My x values are going 1, 2, 3. Minus 1, minus 2, minus 3. And I'll just go up in tens for my y's. 30, 40, 50, 60. It's a very, very rough graph, but just to give you an idea of it. Minus 30, minus 40, minus 50, minus 60. So minus 3 goes down to minus 51, minus 2 to minus 13, minus 1 to 1, 0 to 3, 1 to 5, 2 to 19, and 3 to 57. And when you join it up, you get, so you put it out there, and get that shape for graph, which is correct because it's an x cubic, and there's no other x terms. We expect it to be like that. Question 3 is a reciprocal graph because x is in the bottom, so I expect it to look like a split graph. I'm not told any x values here, so I'll just do a few. I'll go minus 3, minus 2, minus 1, 0, 1, 2, 3. I may need more. If I need more, I'll get more at the end. So starting over here, putting in 3. 3 plus 2 is 5, 16 over 5, which is the same as 3 and a fifth, or 3.2. Putting in 2. 2 add 2 is 4, 16 over 4 is 4. Putting in 1, so that's 16 over 3, and that cancels down to 5 and a third. Putting in 0, 16 over 2 is 8. Putting in minus 1, 16 over minus 1, add 2 is 1, so 16 over 1 is 16. Putting in minus 2 gives me 0. 16 divided by 0 comes up as an error. Write that in as the infinity sign, which is a sideways 8. I'll show you how to graph that later on. I'm putting in minus 3. Minus 3 add 1 is minus 1. 16 over minus 1 is minus 1. Now, to graph that very roughly, my axis, now I know it's going to be a split graph, so I have a rough idea of what it's going to look like. I've got a problem at minus 2. To put your asymptote in there at minus 2, because you can't go through it. Put your points on, up, leave my axes, 2, 4, 6, 8, 10, 12, 14, 16. Minus 1 goes up to 16, 0 up to 8, 1 up to 5 1/3, 2 up to 4, and 3 to 3.2. That is that shape there. You can see what's going to happen with that graph. Because I know the reciprocal shape, I'm happy enough. Minus 3 goes down to minus 1, which is here. And again, because I know the reciprocal shape is going to be, or half, it's going to be something like that. Now, number 4, it's an exponential graph. It's a negative one, so it's going to start high and go down low. So because I know the shapes, makes life so much easier. You're told you're between minus 2 and 2. So working this out. 3 to the minus 2 is 1 over 3 squared, which is a ninth. Add 1, so it's 1 in the ninth. 3 to the minus 1 is a third. You can use your calculators if you want. 1 plus a third is 1 1/3. 0. And 3 to the power 0 is 1. 1 add 1 is 2. Minus 1. 3 to the minus 1 becomes 3 to the 1, which is 3. Add 1, 4. And then minus 2. 3 to the minus 2 gives you 3 to the 2. 3 squared is 9. Add 1, 10. And roughly sketching that together, minus 1, minus 2, 1, 2. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up there just about. So 10, minus 1 to 4, 0 to 2, 1 to 1 1/3, and so on. And if you plot that, you will see your shape heading down like that. And the last one, the cost graph. I'll draw this one out a little more accurately because they're asking questions based on it. So again, it won't be perfect because I'm not using graph paper, but I'll try and do it as neatly as we can. So with your cost graphs, or any of your trig graphs, you always go up in 90s. So 90, 180, 270, 360, 90, 180, 270, 360. It goes up to 1 and down to minus 1, and it's the cost graph. So it is that shape there. Now for part A, I want to know when cost is 310. So what you do here, you go across to where 310 would be. That would be about there, I think. And you go up. Again, if you were doing it on graph paper, it would be much more accurate. And you go across. So it looks like it's a little over halfway, so I'll put in 0.6. You're told it's minus 0.7, so go down to minus 0.7 and read across your graph. Now mine's coming up about halfway between 90 and 180, so I would guess that that's about 135. So x is 135 degrees.